Okay. So two location is
Yes.
there. One is Dubai, another is Hyderabad. So their temperature,
Yes.
outside temperature will be different, right? Here Dubai different temperatures,
Definitely.
Hyderabad different temperature, right? So why we are learning psychometry? So that we can find out all other parameters. Okay, what is dry bulb temperature, what is wet bulb temperature, all these things we have to find out. So that, okay, based on that, we will do all the heat load calculation. Okay, this is the base to
Yes.
understand why we are learning psychometry. Okay, what is the use of psychometry?
Yes.
To taking the reference of psychometric, we will do all the designing, right?
Yes.
So for example,
Yes.
outside temperature is in Dubai, for example, it is more, correct? So for
Yes.
example, around
Yes.
50 you can consider, and inside room you have to maintain
Yes.
uh, 26 or 22 degrees Celsius, correct? Similarly, Hyderabad outside
Okay,
temperature
sir.
is
Yeah.
45 or 44 something, and inside you have to maintain 22.
Yes. Yes.
So the difference is here 22, whereas here
Yes.
the difference is 28, right? So here, if temperature is more,
Yes.
there is more
Yes.
difference. So more cooling, more tonnage is required. Here tonnage will be more.
Yes.
Here tonnage will be less
Yes.
compared to this, right?
Yes.
So based
Yes.
on this parameter, we will find
Correct.
out the
Correct.
tonnage. So understanding this property, we
Yes.
will arrive how to calculate and how we arrive to the tonnage of refrigeration. Okay, TR. So
Yes,
next
sir.
we have
Correct.
different, yeah. So we have different properties of air. First is your dry bulb temperature,
Okay.
DBT. In short, it is called DBT, dry bulb temperature.
Okay, sir. Okay.
So if this is a thermometer, if you keep the thermometer outside, what reading it give? That is your dry bulb temperature. Okay. The
Okay.
temperature sensed by the thermometer at normal temperature is called dry bulb temperature.
Yeah. Okay, sir. This is calling atmospheric temperature also, sir.
Yes, yes, yes.
Yeah, otherwise normal temperature.
Yes. Normal temperature you can consider as.
Yes. Yes. Yes.
Next is your WBT. It is your
Okay.
wet bulb temperature.
Okay.
So here, for example, this is thermometer we have. We have a thermometer,
Yes, sir. Yes.
and in top of that, I will wrap a wet cloth. This is your wet
Okay.
cloth. Like how we
Okay.
after washing our cloth, we keep it in outside, right? So after sometimes you will see
Yes.
the cloth is dry, right?
Sure. Sure. Definitely. Yes.
Yeah, that because evaporate, because of evaporation, correct? Some air from the cloth, it
Yes.
will evaporate
Yes.
to the atmosphere. Similarly here,
Yes, sir.
yeah. So if you wrap it
Yeah.
in thermometer, okay, this is a cloth, wet cloth. If you wrap in the
Yes.
thermometer,
Yes.
after certain times, you will feel
Yeah.
the wet cloth become dry. This is because due to
Yes. Yeah.
evaporation, correct?
Absolutely.
And the
Yes.
temperature sensed by the thermometer is called wet bulb temperature, right?
Okay.
Whenever
Got it.
the
Yes.
wet cloth, the wet cloth wrapped over thermometer and
Yes.
allowed to cool,
Yeah.
allowed to dry
Yeah.
because of the dryness of the cloth is because of evaporation.
Yes.
Okay. The final
Yeah. Reason is
temperature,
it actually
yeah. The final temperature sensed by thermometer is called wet bulb temperature. So out of this, wet bulb or dry bulb, which temperature will be more?
My concept, dry bulb temperature will be more, sir.
Yes,
Yeah,
dry
less,
bulb
less.
temperature.
No, more.
Dry bulb temperature will be more than wet bulb.
Uh,
Correct? Yes. So I'll just share the notes.
because this heat is it will try to equilibrium to with the atmosphere temperature.
Correct.
That's why it
Correct.
is lose the heat from.
Yeah. True. So same thing it is mentioned. It is a study of air and water vapor mixture. And humidity, moisture present in the air is called humidity. Dry bulb temperature, the temperature of air as sensed
Yes.
by the normal temperature. It is measured the sensible heat of air. Okay, in psychometric table, this is the
Okay.
line we see. Okay, vertical line we see. So that is your dry
Yes.
bulb temperature. Next is your wet bulb temperature. The
I
temperature
have one
says,
question.
yeah.
Humidity, how does affect the temperature, sir?
Sorry.
Suppose humidity, more humidity, it will how humidity affect the temperature? More humidity, it will be less temperature, or what does affect humidity?
If humidity is more, okay, temperature may or may not be more. Okay,
Okay.
humidity is moisture present in the
Yeah.
air. Okay, if humidity is
Yes,
more,
sir.
you will feel more
Moisture is
sweating.
water, correct, sir?
You will feel more sweating.
Okay.
Uh, If humidity is more, you will feel more sweating, but temperature will same. Generally, in
Yes.
coastal areas, you will find more humidity. Correct.
Oh, yes, sir. Yes, sir.
And if you see some
This
cities like
humidity is
it is the moisture present in the air.
yeah, yeah, moisture. This is for I think this is also very important to calculate, sir.
Yes.
It will
That all we will
calculation.
calculate.
Okay, sir.
Yeah. Right. So next
Yes,
is your
okay.
wet bulb temperature.
Yes.
Same thing it is mentioned. The temperature sensed by a thermometer whose bulb is wrapped with a soaked wick in a rapid moving wire. Wet bulb temperature is always less than dry bulb temperature. So when the moisture meet the soaked
Yes.
wick, the water evaporates from the cloth. It lowers the temperature measured. The temperature that wet skin feel
Yes.
when exposed to moving air. For example, whenever you are wet,
Yes.
okay, sweating, and you come under the fan. So what happen? You feel little cool, right? This is
Yes, sir.
because of wet bulb temperature. So wet bulb temperature in
Yes.
the psychometric chart, it will be in the slant manner, this slant manner. Correct. Next is your dew point temperature.
Yes.
Okay. Dew point temperature,
Okay. Okay.
it is the temperature at which the condensation start. Dew point temperature. The temperature sensed by. So the temperature at which the condensation start, or
Yes.
what we can tell, uh, the temperature at which moisture leave the air and condense on the object.
Okay, sir.
Temperature at which moisture leaves the atmosphere
Okay.
and condense on the object. Okay, or the temperature at which condensation starts. Generally, in winter, you will find
Means
whenever,
decreasing the
sorry,
temperature will be reducing at that point, right, sir?
Yes, yes. Generally, in winter, you will see whenever you wake up in the morning, early morning, you will find some droplets in the grass, right? Or in some leaf or whatever you keep outside.
Yes.
Okay, you will find some droplets. That is because of dew point temperature. Another example, something, some cone or cane you put inside the fridge and you bring it outside. So what happens? Suddenly, some atmosphere, okay, uh, moisture will be there that will condense on the object. It will fix to the object. So you, whenever you
Okay.
take any bottle or
I,
can from the refrigerator, you will find the some droplets on the.
yeah.
This is because of the dew
Yeah.
point
Droplets.
temperature, right?
Okay. Sir.
Yeah.
In concept, this is, sir, once this moisture, it will uh, uh, suppose moisturing of the moisturing, it is when it leaves from the to atmosphere, then uh, temperature will be reduced, sir, right? It condense
Yes,
will
yes,
start.
yes,
If
yes.
not, yeah, this is depend upon the moisturing. So moisturing
Moisture.
is existed, then it will not. Yeah.
Yeah, yeah.
Suppose moisture is not leave to atmosphere, then
Hmm.
temperature will remain constant, correct, sir? It will not
Yeah, yeah,
affect,
correct, correct.
correct, sir?
Yeah, yeah.
Okay.
Next is relative humidity.
Yes, sir.
Relative humidity means, for example, one bottle
Yes,
tub is there where you can fill water 100%, but it is filled, water is filled 50%. So
okay.
here how much it is? 50% it can fill, 100% it can fill, but it is actual filled 50 upon how much it can maximum fill into 100 percentage. So it is 50%. Correct. Similarly, another
Yes, sir.
bucket completely filled. Actual is how much? 100%.
Okay.
Okay. How much maximum it can be filled?
Yeah,
100%. 100 into 100%.
yeah.
So total is 100%.
Uh, yes,
Similarly, in the room, what is the moisture
yeah.
actually present and how much maximum it can filled into 100? So ratio of actual moisture present in air with respect to maximum moisture it can capture. Okay. So generally the relative humidity range
Okay, sir.
is 30% to 60%. As for ASHRAE,
Okay,
30% to 60%, and most commonly
okay, sir.
50% we will take the relative humidity, RH.
Okay, sir. Yeah. And can you give the again example? I'm not little confusion here, sir. Actually,
Hmm,
yeah.
hmm.
This relative. Still, I
Yeah,
have
I
some
will give
confusion.
example. Hmm.
You,
So example I've given the right, for example, one glass. Okay, there if you full, okay, you can fill the water, but it is
yeah,
filled half.
yeah,
Correct. So in that case, 50% is filled. So it is 50%.
yeah.
Similarly, in the room,
Yes, sir.
moisture can be filled 100%, but
Yes,
how
sir.
much it should be filled? We have to take it, the limit is 50% relative humidity. So ratio of actual water vapor
Okay.
present in the air to the pressure in the air. If the air is saturated at dry bulb temperature, it is expressed in percentage. So relative humidity of air is 50%. So a ratio of
Okay.
actual how much it can, actually how much it is available, and upon how much total it can capture.
Oh, okay, okay,
Okay.
okay. Means suppose we put the water on glass, okay,
Yeah.
full.
Yes, it is
Then it will
100%.
be later it will be reduced. Yeah, it was 100%. Later it will be less, half, right, sir?
No, later we are not
Then
discussed. We are concerned what is present.
oh,
Actual is how much? Actual is
okay.
your field means 100%, right? 100. Okay.
Yes, sir.
Maximum
Yes.
is how much? 100. The ratio of this into,
Yes.
if you want to express in percentage, multiply with 100. So we'll get 100%, right? Similarly,
Yes.
the glass is filled with half percent.
Actually, okay, okay.
So 50 by
Understand.
100.
This ratio of
Yeah. So
okay.
it is, if you want in percentage, you multiply 100 percentage. So you'll get 50 percentage.
Okay, this is concept only because might be 50, 60 also, right? Just concept.
Yeah, yeah,
Maximum we can consider 100. But it will maybe variable. It might be
yeah, yeah.
60, 40, 80, right, sir?
Yes,
Just
yes.
concept, sir.
Yeah.
Okay.
Next is your humidity ratio. Okay.
Yeah.
Humidity ratio. So it is also called as specific humidity or moisture
Yeah.
content. It is the mass of water vapor present in 1 kg of dry air. In 1 kg of dry air, how much vapor is present? In 1 kg
Okay.
of
Okay.
dry air, how much vapor it is
Okay.
present? That is your relative humidity
Yeah.
ratio. Correct?
Okay. Yeah.
So
Yes.
it is expressed
Correct.
in grains per kg of dry air. It is expressed in W, and it is used for
Okay.
to find the latent heat. We will discuss latent heat, all those things. So 1 pound is equal to
Yeah.
7,000 grains. This you remember,
Uh-huh.
just a conversion.
Okay. Okay.
Clear? So
Yes.
in the psychometric chart, it looks
Yes.
like this. Humidity
Okay.
ratio. Relative humidity, it is in this
Okay.
curve. Okay.
Yeah. Yes. Yes. Okay.
So enthalpy is okay. Next is saturated air. What is saturated air? Where all these three, okay, your dry bulb, wet bulb, dew point temperature remain same. That air is called saturated air. The
Yes.
temperature at which dry bulb temperature, wet bulb temperature, dew point temperature are same. That temperature is called saturated air. Correct?
Okay. Okay.
Yeah.
Yes.
So now,
This is equilibrium state of the yes.
yes, yes, that state is called saturated air. Now, psychometric chart and software. So here, for example, one project, if you find out this is the project office building, and we have here we have dry bulb temperature, okay, 35 degrees Celsius, relative humidity 60 things. Here remember, if I want to find out all the properties of air, okay, what are the different properties of air we learned? Dry bulb temperature, wet bulb temperature,
Yeah.
dew point temperature, relative humidity, humidity ratio, okay, and enthalpy.
Yeah.
Is not used that much. So these are the
Yeah.
properties. So to find out the other values, at least you should know two properties of this. Two properties should be known. Then only we can find out
Yeah.
the all other properties. Is it clear?
Yes. Sir. Okay. Okay. Understand.
So here, whenever you use any chart, one we can use through psychometric chart, another through psychometric software. Okay,
Okay.
two ways you can do it. If psychometric chart, here you can see barometric pressure 760 mm of mercury or 29.92 inch of mercury. It is an mm and other is an inch. So you need to see the chart contains what. So here it is, you can see 29.92 inch of mercury, it is there. So it is clear. So then you can follow the chart. So now
Yeah.
here you see dry bulb temperature is 35 degree Celsius. We need to convert into Fahrenheit.
Yeah.
Okay. So we need to convert
Yes.
into Fahrenheit. So how to convert into Fahrenheit? Any idea?
Fahrenheit, I think degree to 275 something. Oh, 200,
That
200.
we need to find out. So for here, you see, this is the conversion to
Yeah,
find out the okay Fahrenheit Celsius. So here
yeah,
temperature is how much? 35. So put 35 here. So this is 7. So
yeah,
F minus 32. Okay, this will be multiplied. This is equal to 63, right?
yeah.
63. F
Yes,
is equal to 63 plus 32. So 5 plus 95 degree Fahrenheit. Correct? So this is 90
yes,
degree, 95 degree Fahrenheit. Only
yeah,
conversion.
yeah.
Okay. So now, and relative humidity, we have 60%. So based on these two parameters, we will find out all other properties. You can see. So here we have dryable temperature 65. So here 60 and here 70. So here 61, 60, 70. 61, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. So here in between is the 65. Okay. So here I'll
Okay.
take this as 65. Another is relative humidity 60%. So relative humidity, this one, correct?
Yes,
This point. Okay.
yeah,
So if you take towards right, you'll have humidity ratio. So humidity ratio is how much? 60. Humidity ratio is 60. Then you go dew point temperature is how much? 50 to
it's
55, in between that 53 something.
yeah,
Okay. Next, here is
yes,
your wet bulb temperature. If you go in this direction, you'll find wet bulb temperature 55, 56, 57.
okay,
Correct. Next, what is unknown? Enthalpy. Enthalpy is on top of that. Straight if you go,
mhm,
you can find out near about 25 degree. Okay. Enthalpy BTU per hour or BTU per pound something is the unit. Correct. So these are the parameters we got it from the table.
okay, sir. For the heat calculation, all the part like that. Later,
For
later we can use it in heat calculation, right?
yes,
So
yes.
from this,
Later all this parameter, what all output we got, we can find out from the used for heat calculation, heat load calculation.
yes, yes,
Okay.
yes,
Next is this psychometric. Okay, if you see, this side is dryable temperature and this side is the humidity ratio. So this side is your
yes, yes,
dryable temperature, and this side is your humidity ratio. Two thing is there. Okay.
yes, yes,
So dryable temperature, humidity ratio. So one point we have taken here, point 1,
okay,
and it is going towards this point 2. So 1 to 2, what will happen? Your dry bulb temperature will increase, right?
Yeah. Yes. Yes.
Another 1 to 3. 1 to 3. So your diable temperature decreases. Correct? Next, 1 to 4.
Yes, sir.
Your humidity ratio will increase.
Yes.
1 to 5. Your humidity ratio decrease.
Yes. Correct.
Next, next is 1 to 6. I will change the color. 1 to 6. 1 to 6, what will happen? Your
Proportional. Proportional.
if you're here, what will happen?
Both.
Both will increase, right?
Yeah,
Drivable temperature
both.
increase
Both.
and your humidity ratio increase. 1 to 7.
Yes.
So what will happen? Drivable temperature increase, humidity ratio decrease. 1 to
Yes.
8. Both will decrease, right?
Yes. Yes. Yes.
1 to 9. Drivable temperature decrease, HR increase, right? If I take like this,
Yes.
HR will increase.
Yes.
So here 5 properties it comes. Okay, it came 5 options. So if your drivable temperature increase, okay, 1 to 2, your drivable temperature increase. So here what you have to do, you have to go for sensible heating. So what option you have to do here? Sensible heating. Heating you have to do. If your drivable temperature decrease, then
Yes.
sensible cooling. Correct?
Okay.
If your HR increases, you will have humidification.
Yeah.
Humidification. If humidity ratio decrease, then dehumidification. Correct?
Yes.
Now here you see dryable increase. So dryable increase means sensible heating plus HR increase. HR increase means humidification.
Yes. Yes.
Dryable increase means your sensible heating plus HR decrease means dehumidification. Right? Then dryable temperature decrease means your sensible cooling. HR decrease means dehumidification. Okay. Your 1 to 9 dBT decrease means sensible cooling. plus humidification, right? So based on this thing, I think it is clear now.
Yeah.
The same thing you can find out here. And which process is used in desert? Cooling or air washer? Cooling and humidification. In desert, you will find this. And in
Okay.
extreme cold area, we will like Antarctica, where too much of killing means cooling is there. There you have to do heating and dehumidification.
Yeah.
Now, 1 minute. Let me open the this thing.
This humidification, how to increase this humidification?
So sorry, humidification.
Yeah. Suppose in desert area, you need to
Hmm.
increase the humidification, right?
Hmm.
Maybe
Hmm.
we need
Hmm.
to give
Humidification means
some
you have to remove the
water.
humidity, right? Humidity is more,
Yeah.
you have to
Yeah.
remove the humidity. Dehumidification means you have to add the humidity. So just for example, in
Yeah.
AHU we have lot of panel. Inside that you have lot of panel. There you can add this
Yeah.
humidifier, dehumidifier, all those things you can add it. That equipment is there
Okay.
that will take care all these things. Okay, it will whenever
Okay.
the air will go,
Okay.
it will have all this
Yeah.
quality
Yeah.
properties. Okay,
Okay. Understood.
right. The same thing, just I will show you the notes. I think meeting will end in 3 minutes. After that, again, you can rejoin on the same link. Right. So what is the use of this? What we learned? So we will understand with some examples. Okay. So take an
Yeah.
example of this Delhi. Okay. So just before we do all the heat load calculation, how to arrive, what process we required, what all things we required. So now
Yes.
Delhi location, summer season, outside temperature, what all we will get: dry bulb temperature 10 degree Fahrenheit, relative humidity is 20 degree, and inside in the room we have to maintain dry bulb temperature 76 and relative humidity 50%. So what is the conclusion here? Dry bulb temperature is, we have to reduce, dry
Yes.
bulb temperature decrease, right?
Yes.
Dry bulb
Yes.
decrease
Correct.
means cooling, correct?
Yeah. 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 Sensible cooling.
Next, relative humidity is increasing. Okay, relative humidity. Here another twist is there. So I think this is related to previous thing. We are not concerned about relative humidity. We are concerned about humidity ratio. Correct? These both are
Yeah.
different. So we have to find out this
Yeah.
humidity ratio for this and humidity ratio for this conditions.
Yeah.
Okay.
Yeah.
So how to find out? We have a software. Based on that software, you can do it, or online also. We can use it. I'll just try to find out some online psychometric. Online, you can use some psychometric things. So here I'll put drivable temperature. Drivable temperature was outside was 110 and relative humidity 20%,
Yes.
right? So
Yes.
calculate. It will tell your where is your these things? Dew point temperature. Okay, this one, right? But the unit is different
Yeah.
here. Change the
Yes.
unit here.